Now see here. Find the volume of the cuboid. Length is given, breadth is given, cuboid is given, and the volume is defined as L into B into H. L into B into H. So 57 into 23 into 94. 57 into 23 into 94. Now see here. Volume of a cuboid is length into breadth into height. You can solve this problem in any method. Let me first use digital sum. Digital sum. 5 plus 7, 12, 3. 2 plus 3, 5. 94, 4. 5 3s are 15, 15 4s are 60. Digital sum is 6. Digital sum is 6. 3, 3, 6. These 6. 3, 6 out, these 8, not possible. 4 plus 2, these 9, it is not possible. 6 plus 3 out, 4 plus 3 plus 2, 1, these not possible. So 3 into 5 into 4, answer is 60. Actually here you can use 57. 57 is divisible by 3. 57 is divisible by 3. Answer should be divisible by 3. If you observe here, 1, 2, 3, 6, 1, 4. 3, 6 out, 2 plus 1 out, 1 plus 4, 5. Not divisible by 3. 3, 4 plus 4 plus 1. So you can eliminate few incorrect answer options just by using the divisibility rule. Options are 34 and 14. In case even if you use the last two digits, 57 into 23 into 94 divided by 100 minus 6 minus 38. 57 into minus 38. 57 into 62. That also will help you to eliminate if the last two digits are different. Last two digits are different. I hope the idea it is clear. Next one. 17 into 11 into 7 minus 7. 17 into 11 into 7 minus 70. You can solve this question in multiple angles. One is divisibility rule. One is divisibility rule. Another is last two digits. Another is digital sum. You can look at this angle in three different ways. Divisibility rule, last two digits and digital sum. Divisibility rule, last two digits and digital sum. Let us look at it one by one, all the angles. This entire number is divisible by 7. Yes or no? 70 is also divisible by 7. Answer should be perfectly divisible by 7. Answer should be perfectly divisible by 7. 7 4s are 28, 9, no. 7 3s are 21, 16, 9, no. 7 5s are 35, 24, no. 364. 7 5s are 35, 14. But there is an option, none of these. There could be another chance. Let us see what are the last two digits. I hope you are all there with me. 17 into 11 into 7. Minus 70. 17 7s are 119. 19 into 11 minus 70. It is 209. Minus 70. Positive remainder is 30. Positive remainder it is 30. So the last two digits, it is 39. Last two digits it is 39. 17 7s are 119. 19 into 11, 209. 209, it is 09 minus 70. Negative remainder minus 70. Positive remainder 30. 30 plus 9 is 39. Last two digits, it is 39. Or in case if you want to see the even and odd concept, odd, it is an odd number. 70, it is an even number. Odd minus even, it should be an odd number. Answer should be an odd number and it should end with the last two digits. Which number? 39. Answer should be an odd number and it should end with 39. So answer for this question is none of this. Answer for this question is none of this. I hope the idea it is clear. Even though it seems like one number is divisible by 7, one number is divisible by 7. In case if it is not by 7, go by the divisibility rule of 11. It is divisible by 11. 11 6 are 66. 4 remainder. Answer when divided by 11, it should give negative remainder minus 4 or positive remainder 7. It should give positive remainder 7. 7, 4 plus 3, 7. 7 minus 6, 1. It is not the answer. You can look at the question from a multiple angles. You can look at the question from a multiple angles. In case we are very sure that the answer is none of these. Why? Because it should be an odd number. These three are eliminated because they are not divisible by 7. These are divisible by 7, but it should be an odd number. A, B, C and D are eliminated. So the answer is none of these. So the answer is none of these. Very, very good question, sir. Very, very good question. Now see here. 338. This question I lifted from the Indian Overseas Bank 2009. 338. 338. Into 97 minus 1835. Idea is to tell you how the questions, original questions are framed. Just giving some sample questions to you. 338 into 97 minus 1835. All the options are ending with 51. Last two digits. So don't use last two digits. Check by using digital sum. If I check by using digital sum, 6 plus 8 to 14, it is 5. 5 into 7 minus 1 plus 8 cancel. 5 plus 3 it is 8. 35 minus 8. 8 minus 8 0. Answer digital sum should be 1. 9. Answer digital sum should be 9. Answer digital sum should be 9. This cannot be. 5, 10, 11. This cannot be. Answer digital sum. 5 plus 3 it is 9. Answer digital sum should be 9. Answer digital sum should be 9. Because there is an answer. There is an answer none of these. There is an answer none of these. What we will do is 338 into 97 minus 1835. Let me check with the last two digits whether it is definitely 51. 38 into 97. 38 into. Check by using the last two digits. I hope it is clear. B, C and D are eliminated. Why? Because digital sum is not matching. We are at A and 3. We are at A and 3. Anyway, it is just by looking at the question itself, I am getting a logic. It is 100 minus 3 minus 835. 338 into 100. It is closer to 38,800. 338 into 3, it is closer to 10,000. 10,800. 11,800. So from these 338 into 3, it is closer to 1,000. It is closer to 2,835. Closer to 3,000. Answer should be closer to 30,000. Answer is 30,951. If you are stuck, anyway it is there. 8573 minus question mark plus 56. It's an easy question. Use last two digits. Minus x plus 51 equivalent to 77. Use the concept of last two digits. Why? Because all the answer options, last two digits are different. 93 plus 51. 144. 144, it is 44. Minus x equivalent to 77. X equivalent to minus 33. Positive remainder, last two digits is 67. Last two digits it is 67. Last two digits it is 67. I hope the idea it is clear. Let me cross check whether first one is right by using digital sum. Cross check by using digital sum whether LHS is equivalent to RHS. Since we are doing a lot of questions, I hope by this time you should have understood how to Check whether left hand side is equivalent to right hand side. It is close to 8,500. 85,000 minus 8,500. 76,000 plus 150. 77,000. It is coming very, very closer. Very, very close. So I think this also you can solve it. Answer should be divisible by 11. Answer should be divisible by 11. I'll give you hints. 21 is 7 and 3. And apply digital sum. And apply digital sum. All the last two digits are quite different from each other. So you can use the concept of using last two digits of a number. Last two digits is 11 into 21 into 11. 11 11s are 121. 21 square is 441. Just by looking at a question itself, B, C, D are eliminated. B, C, D are eliminated. Option A and option E by using digital sum, cross check whether they are right or wrong. Cross check whether they are right or wrong. Another examination question. Which are the two nearest numbers to 19596? 19596. Which are the two nearest numbers to 19596 are divisible by 9? Are divisible by 9. If they are divisible by 9, answer digital sum should be 9. If it is 0 also, it is equated with 9. If it is 0 also, it is equated by 9. 9 plus 9 eliminated. 6 plus 5, 11. 11 plus 1, 12. 12 digital sum is 3. 12 digital sum is 3. For it to become 9, I need to add 6. For it to become 0, I need to subtract 3. 19596 minus 3. 19593. 19596 plus 6. 19602. Extremely easy question. Extremely easy question. I hope the idea it is clear. Which of the two nearest numbers are divisible by 9? 19596. Digital sum is 3. For it to become divisible by 9, either it should become 0 or 9. 3 means I need to subtract by 3. Then I need to add 6. 1596 plus 6. Here itself you got the answer. Plus 6 2. Answer unit digit should be 2. Only one option unit digit it is 2. Only one option unit digit it is 2. I hope the idea it is clear. All the questions which we are discussing in digital sum session number 2 is from the numerical values. Is from the numerical values. Largest number that is exactly divisible by 81. 81 digital sum is 9. Answer digital sum should be 9. This is 9. No. 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 This is exactly divisible by 81. 81 is a multiple of 9. So answer digital sum should be a multiple of 9. Answer digital sum. Next one. Now see here. 14 cube plus 15 cube plus 16 cube and so on up to 30 cube. And so on up to 30 cube. You can solve this problem in multiple methods. Multiple methods. Very, very good question. 14 cube plus 15 cube plus 16 cube and so on up to 30 cube. Now see here. I'll tell you multiple methods. Method number 1. Method number 1. By using digital sum. Method number 1. By using digital sum concept. In digital sum session number 1, I discussed a beautiful concept. 15 cube. What is the digital sum of 15? 1 plus 5, 6. 6 cube is 216. It is 9. 6 power any natural number. If the base digital sum is 6, 6 power any natural number greater than or equivalent to 2. Answer digital sum is always 9. 18 digital sum is 9. 21 digital sum is 9. 24 digital sum is 9. 27 digital sum is 9. 30 cube digital sum is 9. So any multiples of 3 power 3, the digital sum is always 9. Digital sum is always 9. So you don't need to spend your time in doing on this. 15 cube. 9 plus any number. Answer digital sum is not possible. 15, 18, 21, 24, 27, 30. All are multiples of 3. I removed the multiples of 3. So the question became 14 cube plus 16 cube plus 18, 16, 17 plus 19 cube plus 20 cube. Am I right? 18 it is eliminated. Plus 22 cube plus 23 cube. 24 cube out. 25 cube. 26 cube. 28 cube. 29 cube. Are you all with me? 14, 16, 15 is out, 18 is out, 21 is out, 24 is out, 27 is out, and 30 is also out. 30 is also out. Now we will go one by one. 9 it is 9. 2 cube 8. 8 by 9 minus 1. 28. 2 plus 8 10. It is 1. 8 by 9 minus 1. 25. 2 plus 5 7. 7 cube is 343, which is 1. 2 plus 3 5. 5 cube is 125. 1 plus 2 plus 5 8. 8 it is minus 1. 2 plus 2 is 4. 4 cube is 64. 1. 2 cube is minus 1. 99 is out. It is 1. 8 cube 512, which is minus 1. 7 cube 343. It is plus 1. 14. 1 plus 4 5. 5 cube is 125. 1 plus 2 plus 5 8. 8 by 9 is minus 1. Again I am repeating. I am finding the digital sum of this series. 1 plus 4 is 5. 5 cube is 125. 125 digital sum is 8. 8 by 9 minus 1. 7 cube 343 plus 1. 8 cube 512 minus 1. 9 out. 1 cube 1. 2 cube minus 1. 4 cube 1. 5 cube minus 1. 7 cube 1. 8 cube minus 1. It is 1 and it is minus 1. Minus 1 plus 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 1. Negative remainder is minus 1. That means answer digital sum should be 8. Answer digital sum should be 8. Let me check it out. Which answer digital sum is 8? Which answer digital sum is 8? One by one we'll go. These are all some easy questions. In our class, the more and more variety of questions you solve, the more and more understanding you will have. 6 plus 3, 9. 5 plus 4, 9. It is 8. 2 plus 2, 4, 6, 8. 6 plus 2 plus 1, 5 plus 4. It is not possible. 7 plus 2, it is not possible. So only two options we are able to eliminate because of digital sum. Why I eliminated 15 cube, 18 cube till 30 cube? All are divisible by 3. 3 power any number. Digital sum is 9. 9 added to any number. Answer digital sum will not change. Answer digital sum will not change. Method 1. I hope the idea it is clear. Method 2. Method 2. There is a concept which I wanted to discuss. If the power is an odd number, power is k. A1 power k plus A2 power k and so on up to an power k. A1, A2 and so on up to an. If they are in arithmetic progression, then this number is divisible by sum of its bases. Then the number is divisible by sum of its bases. If the power is an odd number, if the power k is an odd number, a1 power k plus a2 power k plus an power k, it is always divisible by a1 plus a2 and so on up to an and so on up to an. One classical example. This is a very beautiful concept, sir. 1 cube plus 3 cube plus 5 cube. Power is 3. 3 is an odd number. What are the bases? 1, 3, 5. 1, 3, 5. Are they in arithmetic progression? Yes. It is divisible by the sum of the bases. 1 plus 27 plus 125. 153. It is divisible by 1 plus 3 plus 5. It is divisible by 1 plus 3 plus 5. Now, with this idea, let us solve this question. Now see here. 14 cube and so on up to which number? 30 cube. Step number 1. Power is an odd number. 3 is an odd number. 14, 15, 16 till 30. 14, 15, 16 till 30. Are they in arithmetic progression? Yes. So it is divisible by sum of its bases. Sum of its bases. So from 14 to 30, there are total 17 numbers are there. Sn is n by 2 into first term plus last term. 17 by 2 into 44. 17 into 22. 17 into 22. That means 22 it is divisible by 2 and 11. Answer should be divisible by 11. And check which answer option is divisible by 17, 2 and 11. 17, 2 and 11. That itself will be the answer. I hope the idea it is clear. I hope the idea it is clear. Check which answer option is divisible. I hope the idea it is clear. If the k is an odd number, a1 power k plus a2 power k and so on up to an power k. If there are any calculation mistake, please do the calculation mistake. These 2 7s are 14, 2 15s are 2 15s are, oh okay. These 14 to 13, all the numbers are there. So total 17 numbers are there. 17 by 2 into 14 plus 30. Answer is divisible by 17 and 22. What is very, very important in this concept? Two concepts you need to know. If k is an odd number, and the base values, they are in arithmetic progression, then only it is divisible by sum of its bases. Then it is divisible by sum of its bases. Then it is divisible by sum of its bases. Second key point. How to find the digital sum for the powers. How to find the digital sum for the powers. Digital sum for the powers. I hope method 1 and method 2 are clear to you. Method 1, this is step number 1. 15, 18, 21, 24, 27, 30. All are eliminated. 14, 5 cube it is 125, 8 minus 1 plus 1. 8 cube 512. 8 cube 512 is 8. 8 is minus 1 plus 1. 8 is minus 1. 4 cube plus 1 minus 1 plus 1. 8 minus 1. 1. 8 cube minus 1. Minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. Negative remainder is minus 1. Please do not waste your time in doing it as 1 minute, sir. In case, 1 minute, sir. Let me use this slide. Suppose if n has 14 cube plus 15 cube, these which method most of the students will use? It is till 30 cube. Students know that sum of the cubes till 13 cube plus 14 cube plus 15 cube and so on up to 30 cube. Sum of the cubes of first and natural numbers is n into n plus 1 by 2 whole square. Am I right? These 13 into 13 plus 1 by 2. 7 by 2. 13 into these entire thing. I'll write down the concept here. That is nothing but a formulae usage here. These nothing but the formulae usage. Sum of the cubes of the first and natural numbers. What is the sum of the cubes of the first and natural numbers? Sum of the cubes of the first and natural numbers is given by n into n plus 1 by 2 whole square. Till here clear? D is given by 13 into 13 plus 1 by 2 whole square plus P. So here you can also 2 15s are 15 into 31 whole square minus 7 into 13 whole square. These are another method. Only thing is that the series, it is 1 plus 2 cube till n cube. This is the sum of the cubes of the first n natural numbers. If it is given as 1 cube plus 3 cube plus 5 cube, then these formulae may not hold good. I hope the idea it is clear. Digital sum for powers, how to do? Point number 1. Point number 2. How to use the concept of if power is an odd number and the base values are in arithmetic progression. How to use that concept? Idea clear? Next one. All numerical value questions will complete at one shot. M equivalent to 2. 2 square it is 4. Again 2 square 4. 8 plus 10 to 10. Answer digital sum is 1. N it is 9. 9. You can eliminate. It is 3. So M plus N digital sum should be 4. M plus N digital sum should be 4. Very, very easy question. Digital sum does not changes even for a decimal value. 2 square it is 4. 2 square it is 4. It is 2. 8 plus 2 it is 10. It is 1. These out. These out. It is 3. 1 plus 3 it is 4. Answer digital sum should be 4. 6 plus 3 9. It is 7. Not possible. 9. 7 plus 6 13 14 22. It is 4. Next one. 8 plus 1, 6 plus 2, 8, 9, 9, 5 plus 3 plus 1, it is 3. Very, very easy question once you understand it. How to find the, even if the upper values are different, you can also find the digital sum of the given powers. Digital sum of the given powers. This digital sum is 1 square it is 1, 1 square it is 1, 5 square it is 25. 25 digital sum is 7. 7 means multiply the numerator and denominator by 4. 25. Multiply the numerator and denominator by 4. 4 plus 4 it is 8. 8 plus 2 it is 10. Answer digital sum should be 1. Answer digital sum should be 1. So first option. These 9 not possible, these 5 not possible, 6 not possible. If the denominator digital sum is 7, multiply the numerator by 4, numerator and denominator. These 1, these 1. 25 it is 7, numerator and denominator by 4, numerator and denominator by 4. Entire question is based on digital sum for numerical values. 8. 8 is multiply the numerator and denominator for 8. How many times like that? 8. 8 times. 8 8s are 68. 8 8s are 64. Answer digital sum should be 1. Answer digital sum should be 1. Wherever the answer option digital sum is 1, that will be the answer. Very, very easy. If the denominator digital sum is 8, multiply the numerator and denominator by 8. Multiply the numerator and denominator by 8. These 8, 8, 8, 8 till 8 times. 8 8s are 64. 64 digital sum is 1. 64 digital sum is 1. This is a question which talks about a concept. If the denominator digital sum is 8, multiply the numerator and denominator. Multiply the numerator and denominator by 8. This question talks about a concept. If the denominator is 7, multiplied by 4. If there is nothing but 9 plus any number, answer digital sum. Answer digital sum does not change. Question based on multiple ways of solving a problem beyond a generic approach. Divisible by 9. Digital sum can be 0 or 9. Divisibility rule of 7 and 11. All the questions whatever we discussed till now are based on number system application of digital sum. The next class is extremely important. We will discuss the digital sum application in arithmetic related problems. That will be the last session of digital sum, so that you will understand when to use, where to use, and when not to use. Digital sum cannot be applied in fractions where the denominator digital sum is 3, 6 or 9. Watch the class again, make a note of every important concept, and watch the classes in the sequential order. In case if you got any doubts, don't hesitate to put it in the Telegram. With love, Anil Nair.